I'm Ryan Nickel, CTO at DSA, and today I want to take you through a very basic mooring design using Proteus Oceanographic. You can see I've already made a project parts library. If I double click on that, all that's in there is just a generic instrument frame I plan on adding to the mooring. I'm going to close this down now. Let's open Proteus Oceanographic. What we're looking at is the Proteus Oceanographic Designer. In here is the design view, and then this is the assembly view here. The first thing you need to do is add libraries for components that you want to work with in the project. So we'll go add library. We add the official parts library that we've already downloaded from the DSA website. And then I'm going to go and add my specific project parts library file as well. Okay. The only thing we see in here is an anchor assembly, which is just empty here. So the first thing we need to do is we're going to add a top float. So we click Add Assembly, and we give it a text label here. I'm just going to call it Top Float. And we go over here to the assembly window now. We add a component to this assembly. I'm going to add a subsurface buoy. Deep water buoyancy, spherical ADCP. I'm going to add the 1500 meter depth rated spherical ADCP. So I'll click select. Now note the inside length here. This is based on the typical frame size with this one. And there's a wet weight of -189. That's corresponding to the flotation. And then the assembly here is giving the same total amount because there's no other components in here. Okay, so what we'll do is we'll add some line here. And we're going to add some wire rope. Mooring systems, 1/4 inch, select. It's given it a default label with the part, the part name itself. Let's change this to 100 meters length. Now note that top floats below this, so we just click on the down arrows here to adjust the position of the component in the assembly. That's a pretty basic design. You can see a basic estimate of the top tension here. This is going to be estimating on a basic calculation just based on the balance of weight and buoyancy in the system. So the top tension is basically the net flotation from the top float, and then the anchor tension, that's going to be more or less the top float flotation minus the wet weight of the wire rope that we've got there, which isn't very much. Now this is a pretty basic design, but I wanted to show you a little bit more of what you can do and take advantage of duplicates and assemblies in the mooring. So the first thing we're going to do is just add another assembly. I'm going to call this connector A just for shorthand. Add another component. Add a connector here. Crosby safety anchor shackle, 1/2 inch. Select. Now note this button is great. It's duplicate. So we'll duplicate that part. Now we've got another shackle. Now both the inside lengths here and the wet weights are adding to the aggregate wet weight of the assembly and also to the aggregate cumulative length of the whole mooring as well. We'll add another one. Sling link, 5/8, 2 ton. I'll just put this in the middle in between the two of them. I wanted to have a little sandwich there. Okay, so we've got this connector assembly below the top float and above the wire. We're going to duplicate here. There's this duplicate button here as well. So we use connector A again, and I'm going to bump it down below the anchor. So super basic mooring. Just wanted to show you how to kind of interact with the assembly layout here and how to make assemblies and use the duplicate buttons, and just take note of the aggregate top tension and anchor tension estimates, wet weight, total dry weight, total wet weight numbers, and how they change with that. So we'll save. I'm going to save this as my subsurface mooring. I'll check out some of the other tutorials that will expand on this particular project. Thanks for watching.